3 is all about algebra, and our first part, I've broken this up into 2 parts. Part 1 is going to be powers and expressions, and then there'll be a second part where we look at integral exponents instead of just the exponents where they are natural numbers. So we will look at that a little bit later on, but right now integral exponents will be later on, and this one will just be powers and expressions with natural number exponents. So first part we're going to do right now is look at the exponent law. So 3.3 is looking at exponent laws. You may have seen this before, so some people may have seen this before, some people may not have seen it before. So this first little part I'm calling an investigation, where we're just kind of working through our rough work and then getting to the answer. So here, that dot is supposed to represent multiplication, so that's the same thing as me doing x, bracket x, like this with 2 brackets, okay? Or this x squared, and you can have a single bracket. Okay, it means the same thing. So the brackets mean multiplication. The dot means multiplication. There was another dot on the word program I was using. It was too small. It wasn't showing, so I chose the bigger dot, but it's now a little bit too big. So this means the same thing as multiplication. You can have 2 brackets, or you can have 1 bracket. You can have the first one in a bracket and the second one, or the first one not in a bracket, the second one yes, or you can put the first one in a bracket and the second one no, but these all mean the same thing. They all mean multiplication. So that means multiply or product. Okay, so that means multiply or product, which is what these mean as well. So same sort of idea. Okay, so here I'm saying it's x times x. There's no real rough work for this one, but when we have an x times an x, what we're going to write is going to write x squared. So this up here is a tiny 2, so it's a little 2. So that we're going to say, the way we say it is we say squared. Squared for 2, or we can say exponent or power of 2. Okay, I'm sorry, little tick marks, so tick marks, not bracket. Okay, so we can say exponent, some people say exponent, or to the power of 2. So that's x squared, or exponent, or power of 2. So when you have 2 of them multiplying each other, then that's what's happening here. So let's try our next one. Our next one here, we have x squared times x cubed. What we're thinking here in our rough work, so there wasn't really any rough work for this one, but what we're thinking here is that we have x and an x. So we have 2 x's. So that's this part. So we have 2 x's. Then potentially we have another set of x's. So times, and then I have 3 more x's. 1, 2, 3. So that's this part. So that's this part right here, the purple. So we have the pink and the purple. So we have 2 x's and then times 3 more x's. So what we're going to do is we're going to write them all together. We're going to go 1, 2, 3, 4. I have 5 x's. We're going to go x to the power of 5. So we can say to the power of 5. There's no other word for that. So there's no squared or anything like that. For 5, we just say to the exponent 5 or to the power of 5. So that means that what we're trying to do is we're trying to go from here, skip the rough work part, and go straight to here. So if you can do that already, that's fine. But if you don't, then this is what your brain is thinking. So whenever I show something in my brain, I do this little bubble, and I go, this is my brain thinking. It's not part of my answer, but it's part of my brain. So this whole part here, the rough work part, is part of my brain work. But you don't have to write that as part of my answer. I would skip to go here, to go to x to the 5. So here, if I have x cubed times x. Now, up here it made sense. We had x times an x, and I had 2 x's. What you're imagining in your head, though, is that you have an x to the 1 and an x to the 1. Again, those you do not write. They're invisible. So those are invisible. So those are invisible ones. Okay, so there's ones here and here. So if there's no exponent, you assume it's 1. If I have an x times an x, I have 2 x's. Here, I have 3 x's, and I have 1 more x here. So that's, again, invisible. So you're not writing that, but you're thinking that in your brain, that there's an exponent of 1. So if that means, based on this, sorry, based on that, we have an x, x, x. We have 3 x's from the first, and then from the second part here, I have 1 x, like that. And I'm just putting the dot there to emphasize that this is where the separation is here in between our two groups. But all together, 1, 2, 3, 4, I have x to the 4. So again, we're hoping that you go straight from here all the way to here. But this is in your brain, you're thinking 1, 2, 3, 4, so then I have x to the 4. If you do it again here, again, you don't have to show the rough work, but you're thinking x, 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 3 for the first one. For the second one, I've got times 1, 2, 3. So what you're thinking in your head is that whenever I multiply, I seem to be adding the exponents. 1, 2, 3, 4, 5, 6. So then you're going to skip right to x to the 6. And we will come up with a rule at the end about what we do. We're adding the exponents, which is our rule. Now, over here, so hopefully that makes sense. Here we're going to try something different. This one here has a 3 in front and a 5 in front. But we're actually saying, so for this one, we're saying it's 3 times x times, and it's going to be, 5 times x. So 3 times x times 5 times x actually could be the same thing as, now watch what I'm doing here. It's the same thing as 3 times 5, and then times x, and then x. So all I did was shift them around. So I put the 3 over here, I put the 3 here, I put the 5 here, and then I put the 2 x's there. So this 3 times x times 5 times x, I can shift them around. So it's 3 times 5 and x times x. So I did 3 times 5, so I put these guys together here. 3 times the 5 are right here, and the x times the x. I just rewrote it in a different order. So that's just saying that you're allowed to write things in a different order when you're multiplying. So 3 times 5 and x times x, so that would get me 15. X times x is x squared. And yes, again, hopefully we're going from here to here. So here, this would be the same thing as me going 7 times 3, and then times x from the first one, and times y for the second one. So 7 times 3, x times y. When you do it that way, again, you're hoping to skip all the way to here. 7 times 3 would get me 21. X times y is just xy. You can't simplify two variables that aren't the same. You're just going to leave them alone. So x times y is just x times y. Okay, let's try that again. So those are the rules, the basic rules that we have here for multiplying. So right now we're looking at multiplying or products. Multiply and product mean the same thing. So it says find the product, or if I say to multiply, it means the same thing. So here, let's see if we've got the rules in our head. If we have 30 times x times 4 times y, I can do 30 times 4 and make it 120, and x times y, which is just xy, and there's no way we can simplify that. Here, if I have negative 5 times x squared times negative 3 times y times z, I can just do the numbers first. So it'll be negative 5 times negative 3, which gets me 15. And I have an x squared times a y times a z. If they are not, times a z right here. So z, I put a little slash through. X squared y z. The z I have a slash through. Sorry, it's just how I do my z's. So if you look at this, what you're saying is that x squared y z, those are all multiplied together, and I can't simplify them. If they're not the same letter, then I can't do anything with the exponent. So you leave it like that. Now what happens if there is no variable? What happens if I have just 5 times 6 times x? Well, I still do 5 times 6, which gets me 30, and then I just leave the x beside it, times x. Okay, again, let's try it one more time. 2 times m times 3 times n times negative 4p. So remember, all of these mean multiply. So I showed you over here. So bracket, bracket, no bracket, one bracket, one no bracket, one bracket, and one no bracket. These all mean multiply. So this is bracket, bracket, bracket. So that means I'm going multiply, multiply, multiply. So 2 times 3 times negative 4, which gets me negative 24. 2 times 3 is 6. 6 times negative 4 is negative 24. M times n times p. If they are not the same variable, and it stays m times n times p. Okay, so now let's mix it up. What if I had negative 2 m squared n cubed times negative 3 m n squared times 5n to the 4? So look, negative 2 times negative 3 times 5. So still do the numbers. Negative 2 times negative 3 is 6. 6 times 5 is 30. All right, so now you're going to go m times n cubed times m times n squared n to the 4. Remember, we're allowed to readjust this. So what I'm going to do is I'm going to go m squared and the m. We're multiplying those two together first. M squared times m to the 1 is m cubed. So just like I did over here, m squared, x cubed. If I have 1, 2, 3, 4, 5, so you're going 1, 2, 3, 4, 5. 3 and 1, so we're just adding it like that. So I have m squared times a m, which would get m to the 3. Then you want to do the, just choosing the color. So we've got here the n's. So the n cubed, n squared, n to the 4. So again, I'm going 1, 2, 3, 4, 5, plus 4 more. I have n to the 9. 1, 2, 3, 4, 5, plus 4 more is 9. So you're counting up how many. So that's the part where we're multiplying it. So what we're doing here, imagine if you will, is your brain thinking, I'm just readjusting these. So I'm saying this is negative 2 times the negative 3 times the 5. I'm doing all the numbers together. Then I'm doing, I'm sorry, that should have been in blue. That should have been in blue. Negative 2, negative 3, and 5. That should have been in blue. The m's are pink, and then we're going to go m squared and m to the 1. So those two yellow ones there. That's these guys here. So I'm just rewriting it. I'm just showing you what was going on in my brain. And then the light blue here is the n cubed n squared n to the 4. So I grab this one, and this one. So m squared m to the 1 is m cubed. 3, 4, 5 plus 4 is n to the 9. And you're allowed to rearrange them when it's multiplication. So multiplication, I'm just rearranging them and putting them together. I don't want you to write this. I want you to just do this one step. So I want you to do it in one step, but this is what your brain is thinking, right? So if it helps you on rough paper, you can imagine that this is what's happening, and then you're going to put it together here. Okay, so try it again without having to rewrite it. So this one here, we're going to go, let's do the numbers first. Negative 4 times 2 times negative, and this is an invisible 1. Negative 4 times 2 is negative 8 times negative 1 is 8. Okay. Then we're doing the a's. I have a to the 1, a cubed, and b. Oh no, so I have 1 and 3, so it'll be a to the 4. I have 4 of them. The b's, I have 2, 3, that's one more, and 4. 1, 2, 3, 4. I have b to the 4. Okay, and then this last one, c's. I have no c's times 1c, c to the 1, c to the 4, so c to the 5. So let's try that again. 4 times 2 is negative 4 times 2 is negative 8 times negative 1 is positive 8. I have a to the 1, a to the 3, so that's a to the 4. Here I have b squared, b to the 1, so that's 3, 4, so I have 4 b's. And here I have no c's, 1 c, 4 c's, so 5 c's. So when you multiply, you're just rearranging it like this in your brain and putting them together, right? Simplifying it. Okay. So the next type of question we can have, we love these ones, are shapes. So it gives you a little bit of context. So what we might do is we might say, can you find the volume? I'll give you a hint. The volume is length times width times height. My L, I do a kind of a cursive L, so it looks like that, so it doesn't look like 1, but it's length times width times height. So you would write that first as your formula, and we do usually assume that you know a little bit of formulas, so volume, you should know this. Sometimes on an evaluation we would give you the hint and say the volume is this as a hint, and then that would start you off. If we don't, you're supposed to know what it is, but sometimes we're nice and we give you the hint. So from this, you would take your volume and say my volume is length times width times height. It doesn't matter which one goes first. You're just going to grab all of them. So when you multiply, it doesn't matter the order that you multiply things. It can be 5x times 3x times 2y, or 2y times 3x times 5x, or 2y times 5x times 3x. It doesn't matter. So we're going to do the same thing. 5 times 3 times 2. 5 times 3 is 15, times 2 is 30. So 30. X times x, and remember that these are invisible ones here. They're all ones. So those are all ones there. Don't write them. They're invisible. Invisible 1. Okay, so you don't write them, but you know that they're there. And you're going to go x times x is x squared, 2 of them, and you have a y. And that's it. You stop right there. That's the expression. So an expression means that you're not actually going to solve for something. You've just got an expression. This is an expression. Okay, so an expression for the volume. For the next one here, find the area of the figure. So area means you're doing length times width, right? So area means you're doing length times width. So area is length times width. But here we have two shapes. We have two shapes. So this is going to be for two shapes, and it's called, sorry, a composite figure. A composite figure is composed, it comes up from the word composed, it's composed of more than one shape. So here, if we look at this, this is actually not one shape, but it's two. You have two different ways to look at this. One way you can look at this is it's two rectangles. Actually, there's three different ways. It's two rectangles attached to each other. So if I cut this shape this way, this would be area 1 and area 2. And you'll notice this is subscript. So that is subscript. 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 Remember, the stuff in the brain is just my brain telling you this. Your brain thinks subscript is under, not squared, not above. So it's not superscript. So subscript. So you're adding the two areas. I'll do two different answers for this. There's actually three different ways you could do this. So first way would be to cut it this way. So if I do area 1 plus area 2, we're going to do length times width on this area. So the length of this area would be 7n and 4n. So 7n times 4n like that. Plus, and so for this one here, we're doing 7 by 4, right? That's the shape we have. Then we're going to do the next shape for this one, and you're going to do it this way. So when you do it this way, you're going to do, now this whole thing is 9, so I want the shorter bit. If I know that's 9 and this is 4, I'm going to go 9 minus the 4, so it's 5. So this side here should be 5. And then this here, see these double tick marks? These tick marks mean they're the same. So this would be 4n. So the double tick marks mean that they're matching, so 4n. So that means that this extra rectangle here is going to be 5n times 4n. Now, you can do this more than one way, and I'll show you in a second. So when you multiply this, it's 7 times 4, so it's 28. N times n, like we said before, is n squared. 5 times 4 is 20. N times n is n squared. These are the same n squared. So if I have 28 n squareds and 20 n squareds, I should put them together and say I have 48 n squareds. So that's one way to solve it. There's more than one way to solve it. There's actually 3 that I can think of, so I'm going to show you 2. Okay, so the other way is if I cut the shape the other way, so horizontally, you can do it that way, but also there's the way with subtraction. So if you want to do it that way, you can as well, but I'm going to just do the same shape. Just redrawing it, tick, 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 tick. This is 4n, this is 4n, then this is 7n, 2, 3, this is 9n, and then we had nothing else. So I'll show you two different ways, but there's actually a third where if you did a big rectangle minus the little one, but I think I'll just stop at 2. So the other way we can cut this, instead of cutting it this way, is what if we cut the rectangle this way and said this was area 1 and this was area 2. So area 1 plus area 2. And again, you can do it also with subtraction, but we'll just do it two ways for this time. Maybe the next question we'll do subtraction. So this here, looking at the big area, so this would be area 1, like that. So for this one, area 1 would be 9 by 4. So 9n by 4n plus, and then this area 2, so you should get the same answer, is going to be, now let's see what we are missing here. So we've got 4n for this side. I need this short side here. So you go and look, this whole side here is 7, and this matching side is 4. 7 minus 4 would be 3n. So this would be 3n by 4n. Right, so we're just slicing bits off. So this together would be 36n squared. N times n is n squared. 3 times 4 would be 12n squared. And you have 36n squared and 12. That gets me 48n squared altogether. So that gives me that. Now, the other last way that you can do it is if you were going to do subtraction. So I'll just show you on a separate sheet. So what you could have done, most people don't like this way as much, is that you could pretend that it was a big rectangle and do the whole outside and minus the little rectangle from it. Most people don't like that way as much. Okay, but that is a third way you can do it.